Dilations. Dilations occur in everyday life in multiple formats. For example, a blowfish dilates or becomes bigger in order to avoid being eaten by predators. We get pictures enlarged or reduced in size. Those are forms of dilation. And when you get your eyes examined, in order for the ophthalmologist or optometrist to view inside of your pupil, they need to dilate it or enlarge it with a special solution. A dilation is a transformation in which a figure is enlarged or reduced around a center point using a scale factor not equal to 0. The center point is not altered in any dilation that happens. Please note that this is the one transformation that does not usually result in congruent figures. Instead, these figures are similar. The scale factor in a dilation is the ratio of side lengths, and it's always written as image side length over pre-image side length, or image coordinate over pre-image coordinate. When the scale factor of a dilation is greater than 1, the dilation is called an enlargement. When the scale factor of a dilation is less than 1 but greater than 0, the dilation is a reduction. When the scale factor has an absolute value of 1, the dilation is called an identity. This is the one case when a dilation results in congruent figures. Here's an example of a dilation. If the pre-image is dotted and the image is solid, what type of dilation is shown? What is its scale factor? Well, if the pre-image is this smaller shape that's here, and the solid image, or the solid figure represents the image, then we have an enlargement. And we can see that we have straight horizontal lines, so let's use those for figuring out the scale factor. So we have this bottom or base has a length of 1, 2, 3, and that's in the pre-image, so that's going to go in the denominator. And in the numerator is going to be the length of that corresponding horizontal side length, and its value is 1, 2, 3, 4, 5, 6. And 6 divided by 3 is 2. If we notice, we could go up 2 to the right 1, up 2 to the right 1, or up 4 over 2, and this is up 2 over 1. So we can clearly see that slope ratio or distance between 2 points for any side length will always form a ratio of 2. And here's the solution to this example. It is indeed an enlargement, and the scale factor is found by taking the base length of the image of 6 and putting it over the base length of the pre-image, which was 3, and that simplifies or reduces to 2. So the scale factor here is 2. And I also noted that you could use any side length and use the distance formula to calculate the distance between 2 points, but since we have a pair of horizontal lines, it's easier to determine the scale factor with them. Let's look more closely at the coordinates of these two figures. What happened to them from the pre-image to the image when the scale factor is 2? Well, we went from point A, 0, 1, to point A prime, 0, 2. We went from point B, 3, 2, to point B prime, 6, 4. We went from point C, 4, 0, to C prime, 8, 0. And we went from D, 1, 0, to D prime, 2, 0. Take a moment to pause this video and think about it, and when you're done, unpause it. It turns out that all the coordinates were multiplied by 2, and that always happens when your dilation is centered at the origin, regardless of its scale factor. Whatever that scale factor is, When the dilation is centered at the origin, you always multiply both the x and y coordinates of each point by that scale factor, and it will always work.